Morning, everybody. Thanks for coming along. And also thank you to Astricon for having me back here to speak. I think I spoke 3 years ago at one of the different Astricon events, so it's really nice to be back. So the talk is about enhancing voice over IP deployments with the OpenSIPS back-to-back user agent. First, I'll just sort of go through who I am and who we are, because we've not been here for the last 3 years. So we're UK-based, and we kind of a software company, and we specialise in putting together sort of products, support, design and deployments based around open source voice over IP software. We see all kinds of things, and we work with all the products pretty much, and we support lots of the products with a lot of our customers. But our kind of main product that we work with is OpenSIPS. So if someone comes to us with a new product, OpenSIPS is usually our go-to SIP proxy. We work quite closely with the OpenSIPS guys as well for support and things. So the idea of this talk, it's kind of a less technical version of a talk I did at the OpenSIPS conference earlier this year. And it's obviously about the back-to-back user agent module, but it's more about when customers come to us, a lot of the times they have kind of what I would call a traditional setup. So you have like a free switch and or an asterisk, or many of them, and they want to add your traditional SIP proxy in front and maybe do some load balancing and scale things up and move things forward that way. But quite often we get quite interesting projects. So once a customer's been on board for a while, they have a new requirement, and there's a whole sort of host and suite of features in OpenSIPS particular that allow you to do some quite interesting things. And one of the modules that we've done interesting things with is the back-to-back user agent. And it took us a while to get our head around it initially, because it's very different to how OpenSIPS normally operates. So I thought I'd just put it together in a talk and just share our experiences of how we've used the back-to-back user agent and sort of what possible scenarios you might be able to use it for yourselves in the future if you're interested. I've tried to go light on the technical aspects, but there still are some technical aspects in there, so hopefully it'll tell a story with some technical pieces in there, and it should be okay for everyone to understand. Okay, so initially, this is an asterisk conference, so I'm just going to very quickly sort of say, what is OpenSIPS, and also what is a back-to-back user agent, and then go through a couple of real-world problems that use the back-to-back user agent module within OpenSIPS. Okay, so what is this OpenSIPS thing? So if you kind of go really back to basics, if you take OpenSIPS, if you just sort of install OpenSIPS and use the basic configuration script, you end up with a stateless SIP proxy. And what this kind of means, and it's kind of important to how the back-to-back user agents work, is that the top left SIP packet, I assume everyone's familiar with seeing a SIP packet, will arrive into OpenSIPS. And OpenSIPS will then forward the packet, and as you can see where the mouse pointer is, it will add a record route header and a via header. And what that means is that OpenSIPS doesn't have to remember the state for that call or that transaction. It means that once the call is set up, you could take the OpenSIPS server away, or any SIP proxy away that operates in this manner, and the call will still be ongoing. There'd be no problems. You'd then be able to bring up the server again, and because the headers have been injected, when the buy message comes through, or if you get an in-dialog request, for example, then the call will still close down successfully. So there's no state required by the SIP server in order to make sure the call tears down correctly. So it's stateless. Now obviously you can add state very easily to OpenSIPS and do lots of nice things with it, but that's kind of where we're starting from for this talk. So what's a back-to-back user agent? So on the left, we have a little diagram showing how OpenSIPS is very nicely statelessly proxying a call. It's added, very simplified example of the previous slide, it's added a record route header. So this is where the SIP packet should flow in the future. But this is what happens when you introduce a back-to-back user agent. You'll notice that here we have the phone on the left is the UAC, and the phone on the right is the UAS, and they're aware of each other because they can, the SIP packets have come through OpenSIPS and they can see each other's IP address in the contact headers, so they know who each other are. So the phone on the left and the phone on the right know that they are talking to each other. The interesting thing that happens when you insert a back-to-back user agent in the call is that now OpenSIPS becomes the UAS. So originally the phone was the UAS, now OpenSIPS becomes the UAS. So OpenSIPS itself is answering the call as far as the first phone's concerned, and as far as the second phone's concerned, OpenSIPS is initiating the call. So they're completely unaware of each other. And obviously this introduces state into OpenSIPS, because OpenSIPS now has to remember, when a request comes in from the phone on the left, I have to then work out where it's supposed to go to and construct a new request for the phone on the right. So you're introducing that state. And you can also say, asterisk and free switch are also back-to-back user agents. If you bridge a call in asterisk or free switch, the phones at each side of the conversation aren't aware of each other. As far as they're concerned, they're receiving a call from your PBX or your media proxy. So I'm just sort of throwing the example out there that OpenSIPS isn't the only back-to-back user agent out there. So why do you need a back-to-back user agent? One of the main reasons why somebody would, one of the main reasons we initially looked at a back-to-back user agent in any circumstance was to hide call topology. For various reasons, if you're when you're sending UDP packets across the internet, sometimes you'll end up with large packets that have many, many record route headers in, and they end up fragmenting across the internet. Sometimes they won't arrive where they need to arrive. So back-to-back user agent will remove all those record route headers and get you a nice simple packet that will travel nicely across the internet. It hides the call topology, so it will hide the internals of your network from your two endpoints. So in the example on the right, say the phone on the right was a carrier and the phone on the left was a customer, you wouldn't necessarily want your customer seeing the internals of all your internal network and then the final destination of the carrier that you're sending the call to. If you used regular SIP proxying, then all the record route headers and the contact header from the UAS, the carrier at the end, will expose all that information to your customer. So it's a nice way to sort of hide the call topology. Again, the trade-off is you're introducing state. But the really interesting thing about the OpenSIPS back-to-back user agent is it lets OpenSIPS behave like an endpoint, and because you have control of OpenSIPS yourself as a developer, you can then take control of that endpoint and do things with it. So you can initiate a re-invite should you want to. You can intercept an in-dialog request, for example a buy. You can initiate your own buys within a call, and you can also initiate call transfers. So you become in a position of control within the call by using the back-to-back user agent. And you can solve some quite neat problems with it. And that's what the examples are going to show today. So for anyone that's interested, or if anyone's watching this back later, just a quick overview of how you would use the back-to-back user agent modules in OpenSIPS. So you would simply load the two modules. There's an entities module and a logic module that are both required. And out of the box, as it were, there's a standard scenario that you can call. It's very, very simple to call it. You simply call the B2B init request function within OpenSIPS, and it will create the scenario that you've seen on previous slides. So you have the phone on the left, the phone, the UAC and the UAS, and OpenSIPS will insert itself in the middle automatically as a back-to-back user agent. You don't need to do anything else. It's simply a single function call. Exclamation marks on the third point down. When you initiate the back-to-back user agent module, one of the things you have to be aware of is that you lose all further control of the call from a routing perspective. So I don't know how many of you are familiar with this sort of routing configuration in OpenSIPS or Camelio. But you can do things. You can add headers, you can remove headers, you can intercept replies, you can interrogate replies, you can fail over, you can do all these kind of cool things. But with the back-to-back user agent module, the scope for what you can do is somewhat limited. basically the OpenSIPS engine, the back-to-back user agent engine, will then take over the call, and then we'll just continue to proxy all the requests backwards and forwards on your behalf. So it's just something to be aware of if you're ever considering using the module. Yeah, so you've got the basic module, topology hiding, really easy to control, but what you can also do is define your own scenarios, and that's when the back-to-back user agent becomes quite interesting. Okay, so just excuse me. So this is the first problem that we had to solve with the back-to-back user agent for a customer, probably around, well, it would have been around 2009, 2010, I think. And the problem that the customer had was they were a large calling card provider with sort of over 1 million customers, and sort of with expansion had come the kind of normal considerations, sort of, you know, we have to provide some POPs, you know, in Europe, we need some POPs in the US, we need to provide some redundancy. So there were essentially multiple copies of a platform distributed around various parts of the world. And the platform worked well. It was sort of as described in this slide. You know, a customer phones in, they hit an OpenSIPS server, it will authenticate the customer, it will allow them to dial an onward destination, and the call would eventually end up at a carrier, and, you know, the calling card service worked, and everybody was happy. But a new feature comes along. How do you play a balance to the customer? You know, you've got OpenSIPS in the mix. OpenSIPS isn't media proxy; it can't handle media. So how do you play a balance to a customer, which is a nice feature for a calling card company to have? So you go through the design considerations, and kind of this is the obvious one. You can say, okay, fine, let's just throw asterisk in there. So you authenticate the customer with OpenSIPS. The customer decides, you know, which destination they want to dial somehow. Then you go to asterisk. Asterisk goes, oh, it's customer 123. Excuse me. The customer has a $10 balance. That means you can make 1,000 minutes to your chosen destination. So, you know, the customer hears that, and then the call gets connected onwards to the carrier. But it introduces problems because you've now got an extra media hop. You may have some efficient routing in place so that you're taking a call from Asia to Europe, and you're making sure that the hop for the media is in the most efficient location. But now you've thrown asterisk in there, which is going to take the media away, and the asterisk is going to pull the media over to wherever you happen to have put your asterisk server, which is fine. You know, you can put an asterisk server in each of your sort of critical media paths. So you've got 2 or 3 locations around the globe where you're anchoring your media. You can install a cluster of asterisk servers there, or FreeSwitch, or whatever you happen to be using. But then you have the problem of call volumes. So if you're running at 1,000 concurrent calls per POP, then you have to be able to handle 1,000 concurrent calls with your media server. So then you have the problem of, well, do we need 2 media servers in every location? Do we need a 4 in case the 2 media servers have issues? So you're basically increasing the size of your estate, and you're also introducing another thing to have to manage and control. And in essence, all it's really doing is just proxying some media once a prompt has been read. So when we were looking at this, this is when we first started to look at the OpenSIPS back-to-back user agent. And this is the scenario that you can construct with it. So again, it's the same use case for the customer, you know, being authenticated by OpenSIPS, but you need to read that prompt out to the customer. So you can, with the back-to-back user agent, you can make a call into a media server of your choice, or destination of your choice, and then you can allow it to hang up the call. So you can allow asterisk to hang the call up, and then intercept the buy with OpenSIPS, and then connect the call to an onwards destination. So that all of a sudden changes things. You don't have to have media servers around the world. You don't have to maintain 4 in each POP. You could even just have a cluster in Europe or in the States. And you know that you're not going to be handling 500 concurrent calls per server. You're only going to be handling a call while you're reading out a balance, because the server is going to read a balance, and it's going to hang up the call, and it's going to probably be idle for 95% of the time. So this is what we did with the back-to-back user agent to do this. And this is where it does get a little bit technical. I'll just try to zoom in on this. How would I zoom in? Not 100% sure how to zoom in, actually. Does anybody know how to? Oh, there we go. Control. That's messed up the slide. Doesn't matter. Can everybody see that? Apart from the fact it's messed the slide up. So the back-to-back user agent allows you to define these XML files which control the flow of a scenario. So it's XML, so it's easy for a machine to read it. Sometimes it's not so easy for a human being to read it, but it does make sense. So what essentially you have here is you're saying we want to have a scenario called CC generic, calling card generic. And when the call initializes, we want to bridge the initial call, server 1, to the initial client. And we're going to take a parameter for who the initial client is. And that's cool. And now we're in state 1 and the call is initialized. And if nothing else happens on the call, the call will just stay in that state. You'll be bridged between a server and a client, and away you go. And in this case, the server would be the customer, the client would be asterisk. So the asterisk is talking to the customer, reading the balance out. You then have a list of rules that you can define. So here we go with the readable XML. So we're basically saying here we receive a request, and the request is a buy, and we are in state 1, and it is the client that has sent the buy. So if asterisk has hung up, essentially is what we're saying, then we'll say, okay, 200 okay for asterisk, and then we bridge the call to the second client being the carrier. And it's as simple as that. Get back to where we were. Yeah, it's as simple as that. And what you end up with is you end up with this. You end up with a call going through OpenSIPS. OpenSIPS again is authenticating the customer, deciding the customer can call the destination they've requested. The call hits asterisk. Asterisk will read out the balance. Asterisk hangs up the call, and as you can see here, OpenSIPS then intercepts that buy, and it initiates a re-invite process. And we essentially get an invite back down to the carrier, and the media is established between the customer and the carrier. So the back-to-back user agent module has allowed us to construct this scenario here, and we've taken asterisk out of the equation, so we don't need it anymore, so it's gone. And it's really useful. And again, for those of you that might want to look back at this later, I've done a very simple kind of pseudocode example of how this might look in OpenSIPS. So you simply give it the scenario. The XML file we were just looking at is the scenario. So you tell OpenSIPS about the scenario, and then, as you may remember, there were a couple of parameters that the XML file refers to. The parameter 1 is here, the asterisk box. So you're constructing a URI that asterisk will understand. It contains the account number, so asterisk can look up the account, and it can read the balance back. And then we have a second parameter, which is the chosen carrier to take the call. So once asterisk hangs up, the call will then be established to the chosen carrier. So again, it's very simple in OpenSIPS to initiate the scenario once you've defined it. Again, the only real downside is you lose control of that call. Essentially, anything you might want to do after this function call in OpenSIPS, you can't. It just gets taken away by the back-to-back user agent engine. Hence why, at the top, all the logic has taken place. So the do routing module has been used to find the best carrier, for example. Okay, so we can extend it a bit more. So this is the same scenario file with another rule. Previously there was only one rule, now there's two rules. And this is saying, okay, so if we're in state 2 and client 2, for example, the carrier should hang up the call, then we'll say 200 OK to the carrier, and we will then bridge the call back to the original client, which is asterisk, with a third parameter. And this basically says, you know, it's a nice experience for the customer. The customer's called, they've heard their balance, they've been connected to whoever they want to call, then whoever they're calling has hung up. So rather than the customer just having a hang up on their side, the call's been sent back into asterisk, and asterisk can now say, thank you for your call, your balance is now $9.50. You know, please dial another number should you wish. So it creates a nice experience for the customer. And again, you're only bringing the media server into play when you actually need to play media to the customer. And again, the scenario, very simplified call flow would look like this. So as before, you know, the call goes into the balance IVR, the call then goes onwards to the carrier, and then we have a goodbye IVR that gets brought into the mix afterwards. So it's a nice experience again for the customer. Yeah, so what's the point? I think I've covered all these points already while I've been talking through, but you know, you remove or reduce your reliability on your media servers. You know, your scaling becomes easier. You don't need media servers at every pop. And one of the big things for us is that OpenSIPS is very, very good at scaling. You know, even with a pair of OpenSIPS machines, you can handle to many tens of thousands of calls. And OpenSIPS is very good at sharing states between two highly available servers in a pair. So we've said that with the back-to-back user agent, we need to maintain states. With OpenSIPS, it's not really a problem because OpenSIPS can talk to another OpenSIPS. It's very natural for it, and it's also very natural for another OpenSIPS to take over. If one should have a failure, or you should want to have one to take over for maintenance, and the state will be maintained between the two because it's a kind of core fundamental feature of how OpenSIPS can be packaged. Whereas scaling across an asterisk or a free switch is a bit more difficult to achieve. And it's more than likely that in a high volume situation, you're probably already sharing state between two OpenSIPS machines anyway. So there's possibly no extra work to do in that respect. But yeah, it's another topic entirely. I think Razvan is doing a talk tomorrow which concerns sort of highly available OpenSIPS. So that could be of interest as well. Yeah, as I say, proxy lets OpenSIPS route and proxy calls because that's what it's good at. And then we let the media servers jump in when we need a media server to jump in because, again, a media server is good at playing media. Okay, so there is another example. If you don't want to define XML scenarios, you don't have to. There's a concept of a management interface in OpenSIPS. And this can be accessed via the command line, it can be accessed via a REST interface, XML RPC. There's a number of ways to access a management interface in OpenSIPS. And the back-to-back user agent exposes some functions you can call. Just a very simple example here. So if you call the back-to-back list function, you'll get a list of all the sessions that you have established with the back-to-back user agent. You can then cherry pick a session that will have information about the caller, the callee, so you can identify, which call you need to cherry pick. And you can perform functions on it. So this function is called B2B bridge, which means it will bridge the call to a new destination. So we have a session ID, which is 1020.30, which you would pull out of the B2B list command. And you can basically say, okay, we know about this call, we want to bridge it to alice@opensips.org instead of to the destination where it's currently bridged. So that would bridge the caller to alice@opensips.org, or you can bridge the callee to alice@opensips.org by simply passing in a parameter. So this kind of thing's nice if you have a dashboard perhaps or some kind of call center and you're looking at the calls in progress and you need to grab a call out and you want to do it via a dashboard rather than via a presence on a phone or something. It kind of gives you the scope to be able to inject commands into OpenSIPS to move calls around and do things that might be useful for whatever your application is. And again, just a simplified flow of how that would work. So you would have a call established from A to B. If you decided to use the management interface commands to bridge somebody to C, which is alice@opensips.org, then all OpenSIPS would do, OpenSIPS would generate a BY, and then it would start a re-invite transaction, and it would re-establish the media between party A and party C. So you've essentially achieved a call transfer. And again, you can also do it the other way. So if you have a call established between A and B, you can also re-establish the call between B and C. You know, if you want to make the callee be transferred to a new destination instead. Yeah, so it's quite a nice little way to sort of dive in there and control your calls if you need to. Yeah, so that's the kind of end of the examples for the back-to-back user agent, and we've used both of those examples and quite large-scale production platforms, and it works very well. And it's now just kind of another tool in the armory, really, for if a customer comes along and we ever need to do something, because more often than not, things do come in that are a bit off the wall or a bit different, and it's quite a powerful little thing to be able to think about and consider when you're needing to move calls around or move media around. So it has quite a lot of uses. Okay, just a quick note on topology hiding, because I think it's quite relevant. At the beginning, I talked about the back-to-back user agent by default will perform topology hiding as an inbuilt scenario, and it will basically hide the two sides of a call from each other. There is actually another, if that's all you need to do, there is actually another module available in OpenSIPS called Topology Hiding, which will achieve the same goal. It will hide the two sides of a call from each other, but you still retain control of the script. So it's, again, if anyone's familiar with using the record route function in OpenSIPS, you simply replace record route essentially with a call to topology hiding, and you can continue to use your script as you would normally use it. So you can do routing, you can intercept replies, you can add headers, remove headers, and do anything you want. So that's all you need to do. Then the topology hiding module is a useful one. And it has the same benefits I think I've listed before of just using topology hiding. You get a reduced packet size. One of the big things that people like about this, I found, is it makes OpenSIPS look like an SBC. So if you're talking to a carrier, sometimes a carrier will not be happy if you're doing an interconnect and they see record route and via headers, and some big commercial SBCs are incompatible with traditional SIP proxying. They only want to see a single contact header and a single via header. And you can simply use a topology hiding module to basically close down the rest of the call flow to your carriers that you're talking to. And as far as they're concerned, then they're talking to another SBC. Okay. Yeah, so just to conclude, it's a useful tool to have there if you know how and when to wield it. You can perform user agent actions with OpenSIPS by using the module. It can save complexity in product design, but it can increase complexity of your OpenSIPS design. Again, useful for bandwidth, media farm usage. Yeah, licensing costs another one. If you only have a limited number of G79 licenses, for example, it means that you only have to use them when you're playing the prompts to the customer. You have powerful sort of external application available to you with the management information commands. But the big thing is you do lose control of the script when you initiate the module. Okay, so thank you. Any questions? Oh, sorry, it's that gentleman had his hand up and sorry.
So when you're in the call with a calling card, and what do you do, or are you able to inject the media if, for example, the customer's account has gone to zero during the call?
No, one of the considerations is you do lose the ability to do those kind of things. I'm sure you could construct some kind of environment where you brought both calls into a conference room, but yeah, you do lose the ability to do that, yeah. Okay, yeah. Sorry, I didn't realize you were...
I think that's a vital question.
Okay, fine.
So if I want to do a media-less...
He's just bringing the microphone.
Suppose in my scenario, there are 80% billing where we don't need media. It's just call transfer to another SIP server. So how can I do that? And only I have to do 20% where I need media to respond, the balance is low or something. So what type of scripting I can do with OpenSIPS?
So is it the same question as the other gentleman? Are you saying that for 20% of the calls, you need to inject some media to say that the balance is low, but 80% of the calls is okay?
If we inject the media, then are we not, the advantage of OpenSIPS is it's very fast in transferring the calls.
Yeah.
And if we put again the media, it will lower the performance.
No, I don't think so. I think the moving a media server in and out it will happen in milliseconds using a SIP reinvite transaction. So the originator of the call will be told that they are going to be connected to a new media endpoint, and then when the new media endpoint comes in, that's when the media will start flowing between the two. So there's no slowdown or delay from the customer point of view. Okay. Okay.
Actually, I don't have a question. It's more like I have an answer
Okay.
to the previous question. The purpose of the back-to-back, it's more the ability to control the signaling. So it's not necessarily oriented to, let's say, to the injecting media. But if you want to do something like that, it's very easy using one of the media relays, like the RTB proxy, which is kind of a side dish to OpenSIPS. Just for the media, you put the media through, and this one has the ability to inject, to play back media without actually doing anything at the signaling level. So if you want to play back, like, okay, no more credit, you just use the management interface to tell OpenSIPS to control RTP proxy, okay, just play back that, but you don't need the back-to-back for such a scenario, just a simple proxy call.
Yeah. Okay. Good answer. All right. Okay. One more.
Sir, in a very simple fashion, in a very simple fashion, one box installation, OpenSIPS installs fine under CentOS.
I believe so, yes. Bogdan may be the best person to answer that question. But I have no problems installing it on CentOS. So.
CentOS. What's the most common way you see Homer working, VoIP monitor working in front of or with OpenSIPS? What's a fashion that you see it working with it?
I've seen it there's the capped agent program that comes with Homer, isn't there? I've seen it. People sometimes choose to install that because that will then hook into the underlying libraries in the operating system. It will grab the SIP packets and will send them off to Homer, and you don't have to then change your script. So it's a kind of a trade-off. Do you want to change your script? If you have to change your script, if you only have one OpenSIPS with one script, then I think the best way is to put the HEP capture within your OpenSIPS script. But if you've got a large estate with several dozen servers, then it may be problematic to have it embedded in your script. So it may be easy just to install a small program that does the listening. So I've seen both ways, and it depends which suits your situation, really.
Now I have an answer for that. So usually you use capped agents to capture the entire traffic, but you don't necessarily want to do that every time. You usually only want to capture the traffic for a specific customer, for a specific user, and for that kind of scenarios you need to have the filter inside OpenSIPS and just mark the user, trace this, just tell OpenSIPS trace this call for this user, and that's it. So this is usually that's how we do it. Lately, with the latest OpenSIPS, you can do other nice stuff like dispatching, like load balancing the Homer traffic. So you can send some customers on one server, on one Homer server, and others on different Homer servers. So it's easier to control it from the script. If performance or filtering the capture data is not something that you need or you're interested into, that probably you can use the capped agent. Otherwise, you should have the logic inside OpenSIPS. At least that's my opinion.
Okay. Thank you.
All right, thank you very much, Peter, for your talk. Sounds like a lot of people really enjoyed it. So just as a quick announcement, I think that lunch, it's not quite ready time for lunch, but David Duff asked me to announce that I think lunch is going to be inside. It's too windy outside. And I think he said it was the Continental Ballroom or something like, I'm sure there'll be a lot of people on tables and things like that where it is. But all right, yeah, so I think that's it. And next in the room, we've got a talk by Mr. Sylvain Borley from the WESO distribution of Asterisk. It is a GUI for Asterisk and a telephony distribution that enhances Asterisk and makes it better, to talk about developing third-party applications with that. But anyway, thank you.